Hello everyone and welcome back to the Thermojov channel. In today's video, we are going to solve one of the simplest but also one of the most useful problems in Engineering Equation Solver or EES. We will learn how to obtain thermodynamic properties of a refrigerant using the built-in property database in EES. If you are just getting started with EES, this is a skill you will use in almost every thermodynamics project. So, let's get started. Our problem is straightforward. We want to determine the thermodynamic properties of R-134a at a temperature of 35 degrees Celsius and a pressure of 900 kilopascals. First of all, we can go to the unit and check the working unit here. So I can go just here and then select the unit system by pressing and clicking on this icon. So this is your preferences. You can select different units. But in this case, the default setting is like this. Temperature unit is Celsius and pressure unit is kilopascal. Our problem also is on Celsius, degree Celsius, and then kilopascal. So we can keep this default setting for this problem. So I will press just OK. Then I can write the input value, the temperature and pressure. So I will start with temperature. I will call it as the T1 here. It's equal to 35. And then pressure, I will call it as P1 equal 900. So the EES will consider this value as Celsius and kilopascal when we enter in the functions. So this is the input value. I can go here. Then for the different properties like entropy, I can go here to the function information. So if you click here and open this function information, you have access to different type of functions. The first one is mass and string function like ABS and different type of mathematical function here. But in this case and in this tutorial, we are just going to use the thermophysical properties. So when I click here, we have two columns here. The first one is different properties like the conductivity, CP, density, and lots of things like enthalpy. And here in this column, you can select different material. So for our refrigerant, we can go and search and find the R-134a, which is here, appear here. So when I select this one, so you will see this is like example that we are going to use. So first of all, I'm going to use and select the entropy. So I can go down and then here you have access different material properties. I will select the entropy. When I click here entropy, so for entropy we need to have temperature and pressure for our input. We can also select another one, but in this case our problem the inputs are temperature and pressure. So I will simply click on the paste. So then we have this example in this window, and then we can change the properties here. So I will press simply on paste, and you see here we have S equal to entropy for this refrigerant. So I will change this S to S1, and then entropy I have T equal T and P equal P. But for our case, we need to replace this T and P with our input. So I will select T1 and paste here, and then I can do the same for the pressure and paste here. So if I just check the equation, you see we have three equations and three variables. These are our variables T, P, and S, and these are three equations. So we can now start to solve this problem. I will press on the solve, and then we have this table here for this pressure and the temperature that our inputs. We have the entropy for this material, which is equal to 0.3714. Then I can go back to the equation windows, and then I can do the same for different properties here. This time again I will go to this actually function information. If you know this function, you can just simply write it down and type here in this window instead of going to function information. But in this problem I will go for all of these properties and find it here. So for the next one I can select enthalpy, and for this enthalpy you will see the unit also. In this case also we need temperature and pressure for our input for enthalpy. So I will press on paste, and then again change this actually character to this one, H1, and then again I will write here T1 and then P1 like this. Then again check equation. You don't need to select this check and see this equation. You can just simply press on the solve button. So another actually property, enthalpy, also added into this table. And then finally I will select another property. It is volume, so I will go to this function information again and go to the end of the list almost. So I will select the volume. For volume also we need two properties here, so I will press on paste and do the same procedure for this actually volume also. So again temperature and then input pressure, and then solve this one, and so this the new columns also will be added here. This we have actually here. And last but not least, if you go to this actually table, you can add the properties of this material, the unit of these properties here. You can just simply right click, and under the unit, if you just double click here, you can select different actually unit here. So I will select kilopascal, for example, for the pressure, and then press OK. You can do the same for all of these properties. For example here, this temperature, double click, select the Celsius, paste, and then OK here. So you can do the same for all of these properties. So yes, that's it. Very simple. You can actually find your thermodynamic properties with giving the required inputs for each of these properties. So thank you so much for watching, and I hope to see you in the next video.